is going to be, we are going to have overview of messaging services. Just like how we go, just like how we discuss auto scaling and load balancer, especially load balancer. We first talk about how EC2, how websites works. Then we jumped into load balancer to have a clear knowledge, right? So for this, before you can understand messaging on AWS, let's take a look at application architecture overview. How does, when we create application, how do we create the application? Or what is your knowledge about application architecture? When developer develops application, there are multiple components that forms an application. If you go to the cornelis.com website now, you can watch video here. You can create an account, put your username and password. You can buy course. So all these are different features with different components. But what the but there is that all of the components, the payment structure or the payment method, the payment method that we integrate, the place that your names are stored for you to open, when you open an account, where your information are stored, when you want to watch videos, where you go, all of these are incorporated into the same application. So this process of putting all the components together in one place is what we call monolithic application. Oh, sorry, I want to show this slide. So when the way application works is that when you have all of these components together, that is what is called monolithic application. And the problem with this monolithic application, or before we go to the problem, the reason why we have all the components together is because all those components need to communicate. Like when you go to the Cornelis Inc. now, if you don't pay, if you don't buy the course, you can't watch it, it is locked. So the payment method is communicating with the video so that it will know whether somebody has paid or not. If not, you can't watch the video, is locked. But immediately you paid, it opens the video. So all these components are communicating together, and they are communicating together. And if you go, if you don't register, you cannot come on the website. And if you don't come on the website, you cannot view the video or you cannot pay. So they are communicating together, and that is the reason why the application are, they are all put together for them to be able to communicate. So application, just like infrastructure, comprises multiple components, and the components communicate with each other or for different reasons, such as sharing of data, fulfill customer requests, monitor or keep the application running. So there is different reasons why they have to communicate together. But the problem here is that when one of these components breaks, it might affect the entire application. So this is a problem of monolithic application. And this process of joining all of them together is what we refer to as tight coupling. It's what we refer to as tightly coupled. Sorry. It's what we refer to as tightly coupled. When you have a tightly coupled architecture, it means that when one breaks, it affects, or it might affect, the other components. If you go back to the Cornelis, if the login method breaks, what will happen? You won't be able to sign in, right? And if you are not able to sign in, you won't be able to watch the video. So you see the problem there. So with the monolithic application, the failure of single components in a tightly coupled monolithic architecture could result in the failure of the entire application. And now let's look at how a monolithic application looks like. You have the main application, which is the architecture. Then we have component one that is merged inside the same code base or the same application. They write all the codes together, or they haven't shared the same architecture together. We have the components 1, 2, 3, and 4, all of them tightly coupled. When one breaks, it affects the second one. So for us to make sure that our application is always available, even when one of the components breaks, then we introduce what is called a microservices. So you need to understand the difference between monolithic application and microservices application, because it comes out in an interview. People want to know your knowledge about the two. So all these things that I'm telling you that you need to know the knowledge, please be jotting them down. If you have not been jotting in this class, please try to pull down things. That is where how you get you pay attention and you get participate. So with microservice application now, we now have what is called a loosely coupled, meaning that we don't have two components that are tightly coupled that can, when one breaks, can affect the other. So each of these components, they are on their own, in their own resources. Even in fact, you see the Cornelis, all the application, all the functionality, they are on single server. All of them are on single server. But with microservices, we can have different feature in different server. So look at this monolithics now. If this server break down, then all the other functions will not work. But when we talk about a microservice, when one component breaks down, it does not affect the other components. Oluchi, what's your question? Is it Oluchi that raised hands up? Somebody raised hands up.
Yeah, it's me.
Atashi, go ahead.
I want to ask, because during the first section we had, you said something about that we're going to have, I think, Saturday and Sunday for AWS and Wednesday for the cloud securities. So is this Wednesday for the cloud? So that way when we're taking notes, we know where to put our notes.
Okay. So everything we are discussing now, everything, Monday, Tuesday, Mondays, Wednesday, Saturday, Sunday, is still solution. It's still cloud practitioner.
Okay.
Everything now is still cloud practitioner. When you have a good knowledge of cloud practitioner, then if you are going to security route, then you don't need to be coming to solution architect class. And solution architect is going to be on Saturday, then security is going to be on Sunday, then solution architect again on Wednesday.
Okay.
Yeah, so 2 days for solution architect, 1 day for security. But why we are doing cloud practitioner now is to give you good knowledge, not that you just jump into solution architect and be architecting what you don't know the foundation. So as we are doing it gradually now, you are knowing the challenges that we are having on-prem before the introduction of cloud. Then we are introducing services that cloud provide. So that is the best way of understanding it. But what we are doing now, it concerns everybody, and this is cloud practitioner. I hope that answers your question.
Yes, it did, because I was thinking, I didn't know when, because sometimes some of the part of the internet is kind of getting towards the security aspect of it. So I'm like, should I put my notes here? Should I write my notes, take notes in AWS or take notes in in the other part. So I was just confused. I just want to be sure so I can
Yeah.
put all my notes in one spot.
So this is just purely cloud practitioner. And when we finish cloud practitioner, I will tell you this is the end of cloud practitioner. Then we introduce solution architect. We are going to be running solution architect and security side by side. So for the old students that they already have good knowledge of solution architect before, they don't need to be coming to solution architect. They just need to come to the cloud security. And those that doesn't have good knowledge of cloud security, they are welcome. And those that doesn't have the knowledge of solution architect, they are also welcome. But I will advise join all classes if you have the time, because we're going to have a lot of projects this time around, and we are not waiting for the end of the class, end of the whole section to do the project. Immediately we finish one module, we are going to be introducing the projects as well. All right, so now we have a microservices that now uses a concept of loosely coupled architecture, meaning that when one component fails, the other will continue to work. The other will continue to work. It doesn't affect each other. So AWS also provide services that we can use for loosely coupled architecture. Now, before we jump to the AWS services that we can use for this loosely coupled architecture, one thing that you should ask now is that, looking at this architecture or diagram that you are seeing, this is component one, might be your server, this might be your database, this might be your front end, it might be your customer logic. When we talk about customer logic in software development, it just means that, like, an application. For instance, somebody click something on your browser, maybe when somebody, like here, what we have here now, job is, if you submit your resume now, you just go to our backend and we might use that for you to do something. So that is business logic. So when somebody click these courses now, then it goes to the it goes here. Then when somebody click here, it take them to another place to watch the video. Those are the business logic about the application. So I'm not watching it. So now go back. So when you look at these components, they are communicating. They are still one way or the other be communicating to each other. So what happened if a user go to the front end and it performs a business logic from the front end, then the business logic is not responding, then what happened? Would the user still be able to complete the transaction? Absolutely no. So despite the fact that we have a microservices, all the applications, they still need a way to communicate to each other. They still need ways to communicate. And if the application or the component have to directly communicate to one another, then we still have the same problem that we have when we are dealing with monolithic application. Because just imagine, if you have a server that is not responding, maybe the server is dead, how can you use the database? It's still not possible. How can you use the front end? It's still not possible. So indirectly, they are still tightly coupled. So we need something in between, that this component one will not be communicating directly to component two. So that way, they are not tightly coupled to each other. So AWS introduced multiple services that we can use for loosely coupled application. And the first one is what we call the SNX, which is called the AWS simple notification message. So this simple notification message, it sends notifications to users. It takes message from one person and it sends it to another person. It takes message from one application and it sends it to another application. So that is what SNS do. It's an Amazon web service that automates the process of sending notifications to subscriber attached to it. So if you don't know what a subscriber is, let me show you this. This diagram, I don't know where I threw my pen, so this is not, it doesn't make me annotate very well, but I will manage this. Let me show you this. How many of you have ever signed up for a newsletter when maybe your favorite website, when you are filling the website, they now say, okay, if you want to be getting information from us, put your email there, and you put your email, you click submit. What you do is that there is what is called like a container, but we call it a topic. So that newsletter that you put your name there is what is called, that is what like SNS does. So you put your email there, you put your email in that newsletter, you put your email there is what we call the subscriber. Is my subscriber correct? Manage it. Is what we call the subscriber. Why the company that want to be sending you that email is what we call the publisher. So the SNS uses what we call a publisher and subscriber methodology. And in short, it is what we call, when you hear this in IT, they call pub sub. So when somebody asks you in an interview that what do you understand by pub sub, so this is what they mean, that a messaging method whereby a subscriber push messages to a topic. A topic is maybe what you subscribe to is that notify me when there is a new arrival. Maybe those of you that like clothing, maybe when there is a new arrival, notify me. So this new arrival is a topic. So this publisher, whenever there is a new arrival, is going to send the message of new arrival. They must have created a container or a section for new arrival message. So immediately there is a new arrival or new clothes, they're going to trigger this new arrival, and everybody that subscribed to that new arrival notification, they will get a message. So this process is what is called a publisher subscription, and it's what is referred to as a pub sub method. So the SNS uses pub sub method. It uses publish and sub method. So now it uses a publish and sub approach to distribute the traffic. In this kind of approach, the publisher publish a message to the topic. We have a topic, going to create a topic, and once there is a message, it pushes to that topic, and everybody that subscribes. So you have to subscribe to that message before you can get notification. And when you register your bank account and you say, oh, whenever there is a withdrawal in my account, I want to receive an alert. That is what you are doing there. That is a messaging that is a publisher subscriber messaging approach. You subscribe to it. So anytime there is a message, you are sent that message. You don't request again, like, hey, somebody, there is a withdrawal in my account. Can you send me an alert about it? You don't do that again because you have already done that. You have already subscribed for that messaging. So that is what SNS does. So the subscriber immediately receive message for their topic they subscribe to. So this is the pop sub. And in real life, which we are explained earlier, if you subscribe to any newsletter, this is what you get. Oh, I missed a diagram here. So I don't know what is happening to all my diagram. I have a diagram here too, like an image, but you don't need to worry about that. It's just an image that is showing the SNS logo. So don't bother if you don't see it. I think I might do something to it. So, okay, give me 1 minute. Let me view this thing. I think maybe when I'm doing something, everything is rearranged. Let me see. I hope I'm recording the class, right?
Yes.
My slide are not they're kind of messed up. Let me quickly rectify that. Okay, I think it's only, okay, I think I'll be using this. I'm seeing it here, but I'm not seeing it here because I'm presenting. So it's here. This is what I actually want to show you guys, but it's showing on the slide, but it's not showing on what I'm presenting. So what I will do, I will continue using this. So I'll just do share. Oh, not share, sorry. Slide. Okay, yeah, this is what's supposed to come up first. So this is if you are doing architectural diagram on AWS, you will need to be using the icon of that service. So this is the icon of AWS SNS topic. I mean, AWS SNS, which is simple notification service. So as I said earlier, we have it's a notification process of sending notifications to subscriber that's attached to that topic. And it uses a pop-sub approach, and messages are published to the topics, and subscribers that are subscribed to that message, they will immediately receive notifications about the message. And if you have subscribed to any newsletter or email alert, this is what actually happened behind the scene. This is actually used to send notification. So this is not necessarily mean that it has to be a person. You might see when we talk about components initially, when we talk about components, So you see all these components that are communicating to each other. Then there will be like a messaging hub, SNS, in between here, somewhere here. There will be an SNS somewhere here that is listing. So each of these components will subscribe. So component 2 will subscribe to a message. So this might be the publisher. So whenever this publish a message, instead of sending it directly to component 2, what if component 2 is not available? Then the SNS topic, it will push the message here. So this will hold the message pending the time component 2 is available again. This will hold the message pending the time component 2 is available. So anytime component 2 is available, it's now the SNS that will now send the message out. So component 1 has done his own part, he has pushed the message and he has forgot about it. So if component 2 is not available as at that time, then it's none of his business, because this is the problem. If there is no SNS here, do you know what is going to happen? If component 1 send this component 2 a message and component 2 is not available to receive the message, component 1 too might just stay there waiting for component 2 to receive the message. And if component 2 is not available, then component 1, because he's waiting for component 2 to be available, that means component 1 too will not be available for a new request. So now that we have an intermediary man, which is the SNS topic, so component 1 will just send the topic and we host the topic. This one will just hold the topic. Then anybody that subscribe is sent to them. Anybody that subscribe is sent to them. If they subscribe, is sent to them. But now, this can now continue operating on its own like nothing happened. Even if they are not available to take the message, that is their own cup of tea. So, but anytime they are available, it's now the messaging application or the messaging device or service that will now send that message out. This is for sending messages. Now, there is another one for that we use for loosely coupled approach. And this is called the queue service. This is called the queue service. So unlike the SNS, this is using a push and pull approach. So it still it's still kind of like a subscriber, and it's still kind of a subscriber and a publisher and a subscriber. But instead of sending out messages to the subscriber is actually the one that pulled the message. So we call this queue. Now, let's look at an example. The example that I explained earlier, if this application here, if the 3 of them needs to communicate, 4 of them needs to communicate. Let's say they are producing something. If this application here produce this ball as its own output, I need to send the ball to this person here as input. When it sends to this person as an input, right? What will happen if this person here is not available to receive the input? That means this will just continue producing And it will come to a time that it cannot produce again because what? You don't have where to store it. So indirectly, despite their microservices, it will still affect, they are still indirectly tightly coupled because it now has limitation because of this one capacity. So what will happen if we have something like another middleman that whatever this one is producing, it can just pass it to this person here. It will produce, it will pass it here. It will produce, it will pass it here. It will produce, it will pass it here. Then anytime that this one is available to process or to work on the output of this, anytime he wants to take in any of these products, then he has to pull it. He has to pull it. So now, this one does not, this component 1 now does not have to wait for when this component 2 has capacity to take more resources or to take more end products. So it can just continue producing and be pushing it in the queue. We call this queue. So anytime that this component 2 is ready, it will just come to the queue, it will take one, it will work on it. And when it finish, it will delete it here. Then when it's ready again, it come here, take another one, work on it. When it finish, it delete it. This process is called queue. And this is what AWS services is used for. In the AWS services called the simple queue service. So all these methods, these two services are used for ensuring that we don't have what is called a tightly coupled component. We don't have a tightly coupled component in our infrastructure. So if you are working as a solution architect, this is one of the things that must always come to your mind whenever you are drawing any architecture or whenever you are doing any architectural diagram. You must always make sure that you don't have resources that when it breaks down, it can affect other. So this is the process of loose coupling, loosely coupled approach. So now, what we will just have is that a centralized queuing system that only takes in data. And we are still going to discuss this on SQS. This SQS, we are still going to discuss this when we get to solution architect, but this is just the basic. So now you know what this queue service is meant for. So you know services that we can use to ensure that we don't have the challenges of monolithic approach in our application. So instead of having monolithic approach now, you have microservices. And when you are dealing with microservices, if you don't have a way to ensure that you can make sure that no two components will result in the, no two components can, no two components are tightly coupled, then if you can't ensure that, then that means your application will not be highly available and it will not be fault tolerance. Because when we are talking about fault tolerance and highly available application, an application that can be that can stay or that will be available at every point in time, that the problem or the failure in one other application or the components of another application will not affect it. That is fault tolerance. When one application is down or one component is down, it doesn't affect every other component. So that is the loose coupled approach. So we're going to end the class here today and continue from here on Saturday. So on Saturday, we are going to be looking at another compute service that is in the cloud, which is called Lambda and container. So when we meet on Saturday, we're going to be discussing on this. So your takeaway from whatever we've been doing is just, you know, the service, you know the challenges that we employ, I mean, you know the challenges that business normally have before they migrate to the cloud. Now that they are on cloud, what are the services that is available for them? So any question for me? Any question? No question, because some people are already sleeping. Nelson, I've never been hearing your voice.
I'm here.
I thought you were sleeping. That's how I used to know those that are sleeping. When I call you and you don't answer on time, I know you are sleeping.
I'm here.
All right.
How do we find a copy of the slides?
Tina, what do you say?
The slides, where do I find them on the website?
Okay, let me show you. Thank God that you say, where can I find them on the website? I want to say it's in Kansas. But because you put on the website, I'm going to show you. I want to stop the recording.